Testing, testing. Right. Now my audio should be here. Again, let me know. I'm not sure why my other mic is not right now. Give me 1 second here. Good thing I started a minute early. All right. That looks like it's working now. Again, if you want to let me know in the chat that you can hear me. It looks like I see the audio bubbles now, though. Should be good. Not sure what happened there. And we're a minute early, so I'm sure people will be joining in here in a little bit if you're already here. Like I mentioned, say hello in the chat. I'm going to bring up some slides. If you've been here before, you'll be familiar with the format, but I'll go through a quick intro as well. Again, I'm going to wait probably just a couple minutes for people to roll in. So while that's happening, say hello in the chat. I'm going to type in there right now. I know also last time I had an issue with the chat not showing up. So let's see if that's fixed this time. All right. I'm going to look at the LinkedIn Live because, yeah, last time the wasn't popping up on the StreamYard feed, which is what I'm streaming in. It looks like that might be the case again. I have a theory of why that's happening, though. And so for the next one, I'm going to on LinkedIn and then connected the StreamYard to it. And that might be what's causing the weird thing for the LinkedIn chat not to show up, which is kind of a shame because it's kind of nice when it surfaces up in the event here. But you just might not see it on screen. Keep talking in the chat. I'm streaming on YouTube and LinkedIn. So I just might not show the comments today in the stream, unfortunately, which kind of helps with the cross-platform thing. But if it's not working again, I'm going to disable that. And just talk in the chat. And if I see interesting comments, I try to read them and bring them in. There's also an option for you to join the stream later as well. So I'll share that link out when we get to the discussion piece after kind of the intro. But it looks like I'm just going to have to read the comments manually. So I apologize for that. I think I might know how to fix it next time, but I can't reset up the stream since we're already live. So I'll do that next time, and hopefully that's going to work out. And I see a whole bunch of people rolling in. Hello, hello. I'm going to say hello in the LinkedIn chat as well. Oh, also, I'll share both the links. Some people like streaming on YouTube. Some people like streaming on LinkedIn. So I'm actually just going to share both of those in the chats as well. I found that the LinkedIn one is definitely, at least for me, is more, there's more chatter usually going on in there. And I've usually linked the stream to that. Now I kind of do both. All right. I think I see enough people. And again, I'm just going to pull up my other window so I can make sure I see the LinkedIn chat as well. And yeah, apologize for that happening again, but I think this kind of confirms probably what the issue was. All right. So, well, oh, wait, it's working now. All right. Chat, I don't know why it wasn't working. Now it's coming through. I can see both. I can put them in the stream as well. Welcome, everyone. This is the AI Book Club for AI Systems Performance Engineering. Again, most people like discussing in the chat. I will share a link, though, if you do potentially want to join the stream later as well. See some questions coming in. Someone said, is there a list of books that are to be reviewed for this year? I'll cover that here in a second. So let me go ahead and get going on the slides. I think this will answer some of the questions. As you're joining in, though, like I said, say hello in the chat. Also, maybe you want to put where you're watching from, what you're building, why you're interested in AI performance engineering or any of the other topics. That's always fun to hear about. So I have some slides. Again, this is the book. I will share this link in the chat as well. So if you haven't checked it out yet, go check out this book. It was really good, very interesting side of things that I haven't gone as deep on myself all the time. So I thought this is a really interesting book. And again, we'll cover the topics here if you haven't read it yet. A lot of people just come in and kind of enjoy the discussion around it. And hopefully you'll want to check out the book later as well. This is also the um, GitHub link for all the code in the book. So if you want to just look at the code, he also has links to a lot of his other stuff like YouTube videos. So Chris Fregly, he's done several other books that are really good, and I would recommend following him. And also, a lot of people want to get the slides, even though usually this is just kind of a not a format of the book, but like I kind of just capture the chapters. But if you do want to check out the slides, they're in here, and then we'll just kind of break up the chapters. Well, we'll go through, talk, look at the chapter list, and then usually I've broken that out into slides per chapter with some subtopics. This time I also did a little bit of my takeaway as slides, so I'll talk about if we want to talk more about that or go through chapters. It's up to you. And someone said, "Are you just starting the AI book club?" Or already got something in the middle. So the AI book club's been going for a while, but this is the first discussion for this book. We've been doing a book a month for just over 2 years now. It started originally not as a book a month, but it kind of evolved into that. All right, so let's get going down more of the slides. So again, a lot of people joined in. It sounds like some are new here. In short, we've been reading a new book every month, and then we discuss online. There's also a Slack channel if you want to discuss it kind of during the week that I'll share out. So there's a AI reading club channel in there. I usually make a thread in there. It's usually been a bit of quiet during the months, and then we mostly discuss online here. But it would be cool to get it more get it going again. And then there's a GitHub that has a list of all the books. So that person who asked, is there a list of all the books? This has all the ones that we've read in the past. So I'll share that as well if you want to take a look at it. And I'm open for book suggestions. Actually, we'll talk about that next. So far for this year, last month we read Hands-on Machine Learning with Scikit-Learn and PyTorch. It was really good. Also a pretty beefy book. I don't know if anyone read the book this month, the AI System Performance Engineering. It's over like 1,000 pages. And I picked a bad month for it because February is a short. I could have used probably another week to go through it. But hopefully you went through it or part of it. It's okay if you didn't finish the book or even read the book. If you just wanted to discuss the topics, that's kind of what this stream is about. And then hopefully you'll want to check out the book later as well. And then the next book that we're going to read next month in March is Context Engineering for Multi-Agent Systems. It's way shorter, so I'm kind of excited for it. And the content sounds good as well. But it should be a lighter read versus these two books were both, I think this was almost 1,000 pages and this was over 1,000 pages. And then the second edition of Data or Designing Data Intensive Applications just came out. People have said this is a really, really good book. I have not read the first edition, but people love the first one. We're going to be reading that in April. And then the other months, I'd like to hear what you want to read. So these are usually I share different books and people kind of talk about what they want to read next. And we add them to the list. This was what we read in 2025. I won't go through every single book, but just to give you an idea, let me know what books you want to read next and we can add them to the list. And you can message me on LinkedIn or in the Slack channel about that. And then here's some books that are coming out or some are already out. Somebody asked if we could go through a more foundational like theory book. This one looks really good for it that my coworker recommended as well. I don't think it actually has like code in it. It looked like it's mostly the math behind it. But if people are interested in doing that, it's a pretty up-to-date one. So if you ever read Deep Learning by Ian Goodfellow, which is kind of like the classic one, it's like that, but more modern. So it has like diffusion models and transformers in it. It seems pretty good, but let me know what you think. Someone asked for the Slack link again. Let me share it one more time. And it's in the slides as well. Did that not share? All right. So again, the format, we'll talk in the chat and I'll share a link out on LinkedIn as well. So if you do want to join the audio piece and come up and actually discuss like the chapters when we get to that point, you'll be able to do that as well. And then quick shout outs. So this is always kind of a fun part too for people in the community. If you want to say anything before we dive into the chapters, are you hiring? Are you looking for a job? Do you have any awesome projects you want to work on or that you have worked on that you want to share? Feel free to share anything in the chat right now along those lines. Um, what was I going to say? Or if you're like hosting an event that seems interesting, let us know. A couple things on my end. Well, hopefully other people are going to share some stuff out as well. Is tomorrow I'm hosting a workshop, so we'll be going through hands-on code and implement a research agent using LangGraph, Tavily, and Flight. I don't know if you've used any of those tools before. LangGraph's the popular LangGraph framework by LangChain. Tavily is a agentic search tool that makes it really easy to give like searching functions and different types of stuff to your agents. And then Flight's our open source AI orchestration platform that we maintain at Union. If you want to check that out, you can actually see the 2.0 SDK is out, and there's some really exciting stuff that I'm going to be talking about. Actually, probably tomorrow at the workshop, and then next week as well. So if you want to check that out, you can. Oh, and then one last thing is I'll say that we are hiring at Union as well. So I'm going to share the link. Actually, let me get the career link real quick. Check out our career page, and then also keep checking it out. If you don't see a role that's right for you right now on there, I think we'll be adding more this year, probably quite a few more, I hope. Any other shout outs from anyone? What other people have going on? Again, are you looking for a job? Are you hiring? Are you happy with exactly where you're at? What books do you want to read next? Put in the chat. Let us know. Otherwise, I'm gonna keep going and talk about the chapter overview. But I'm gonna pause a minute for people to put something in the chat and get a drink of tea. And just making sure comments are coming over again. Sometimes there's a delay. All right, looks like they are. All right, well, if you come up with something you want to share, feel free to do that in the chat at any point during the event. So I'm going to go through, there's a lot of chapters. Like I mentioned, this book actually was, well, it felt harder in a way to kind of build a summary than a lot of the other books we did. Also, a fair amount of the chapters are kind of in domains that I'm somewhat less familiar with. So yeah, it was kind of interesting to go through and try to distill some of this. Actually took a little bit more time to make sure I could distill some of the topics, but I'm going to go through, I'll read the chapter summary. And then, like I said, usually what we do is like go through and break down the kind of each chapter and some of the sub chapters. And again, I'll share a link. Actually, I could share a link now if people want to join up on the stream. It's also okay if you just want to talk in the chat as well. I'm going to put this in the LinkedIn stream. So if you do want to discuss any of these things, feel free to come up. So the first, it goes introduction and AI system overview, and then we'll break these out more. But if you have any notes on these, let me know. Also, let me know if anyone actually read the book. I didn't even ask that question yet, I don't think. Did anyone read the book or part of the book? And it was a beast of a book to get through. So if you were trying to do it in a month, totally get if you did not do all of it. And Ram shared, if you're in the middle of Tennessee, Nashville, for the first weekend in March, come to DataTune Conference. You can check it out at datatunconf.com. Sounds cool. I'll go look at that and maybe bring up the link here in a little bit too. Chapter 3 was OS, Docker, and Kubernetes, tuning for GPU-based environments. And then we had chapter 4, tuning distributed networking communications. Oh, one thing I thought this book too had the most acronyms I've seen ever throughout just like every chapter, which I like. I don't blame them. I think you have to, but just so many of the networking protocols and different protocols all had acronyms that were just. It was just interesting to see. I don't think I've seen that many in a book before. Chapter 5 was GPU-based storage and input-output optimizations. Then we had GPU architecture, CUDA programming, and maximizing occupancy. Then we had profiling and tuning GPU memory access patterns. Then we had occupancy tuning, warp efficiency, and instruction level parallelism. Again, we'll break down, at least I'll do either my takeaways or break down these chapters more, whatever people end up wanting to do. Increasing CUDA kernel efficiency and arithmetic intensity. we have chapter 10, infra kernel pipelining, warp specialization, and cooperative thread block clusters. Some of this might be sound foreign to you. That's totally okay. So, some of the words like I wasn't super familiar with, or at least like wasn't last year. And then we had chapter 11, inner kernel pipe, inner kernel pipelining, synchronization, and CUDA stream order memory allocations. Chapter 12, dynamic scheduling, CUDA graphs, and device initiated kernel orchestration. Then I kind of really liked, for me, like this is interesting to go maybe deeper into a lot of the GPU architecture and specific things in like some of the Linux operating systems and stuff like that. It was almost a lot of this, not all of it, like this Kubernetes Docker one. Um, I don't think it was necessarily the case, but a lot of it felt even more low level than like I would probably be dealing with a lot of on my day-to-day basis. But then after in chapter 13, or maybe starting in chapter 12, and then onward, I thought these were really, really good and really, really interesting to me. Like I really enjoyed this chapter 13, profiling, tuning, and scaling PyTorch, because it really gets hands-on with libraries that I'm using all the time, like PyTorch. I'm guessing a lot of people here have used PyTorch. And then chapter 14, PyTorch compiler, OpenAI, Triton, and XLA backends. I don't know if anyone's used Triton before. This is kind of cool to, like, I've heard about it. I've looked at it before. I hadn't actually gone and implemented any specific Triton code myself, but it's kind of like OpenAI's um, way of building CUDA kernels, but it's more Pythonic. And actually PyTorch uses it under the hood in PyTorch 2 for the PyTorch compiler part, which again, we'll talk more about that more if you want. And then we had multi-node inference, parallelism, decoding, and routing optimizations. This goes more into, I think it was this chapter, again, I'm blending some of them in my head a little bit. I think this is talking about routing optimizations for LMs as well, if I'm not mistaken, unless that was in one of the other specific chapters. Then we had chapter 16, profiling, debugging, and tuning inference at scale. Then we had scaling, desegregated prefill and decode for inference, advanced prefill, decode, and KV cache tuning, and dynamic and adaptive inference engine optimizations. And then last but not least, AI-assisted performance optimizations and scaling towards multi-million GPU clusters. Sounds crazy if you're running on a multi-million GPU cluster. But I don't know, building a lot of data centers, we'll see what happens. So I'm going to pause real quick before we move on and maybe break some of this down. Again, if anyone read the book, or even if you didn't read the book, what chapter here sounds the most interesting to you? And I'm going to catch up on the chat a little bit too. I see Arun said hello. They have an embedded system career background, and let's see, and a dated but foundational ML knowledge from grad school. And they're interested in having an all-rounded and updated knowledge of AI. Checked out the book. They checked out this book, I think, for a little bit, especially a chapter on hardware, since that's the start, but it's quite lengthy, as I just mentioned, and eventually a pause in favor of the more foundational books. So they did up looking into CUDA programming afterwards. Yeah, I think I would say, like, if you didn't already have a ML background and you weren't specifically trying to get into like CUDA kernel programming or something like that, this book might seem a little daunting. So I want to say that don't be discouraged if you're reading this book and it felt scary. I think this is for kind of a specific, either a more niche group of people that want to get in that field, or if you already have a background more in machine learning, deep learning, and you kind of interact with some of this stuff, but you want to go deeper into it, this provides like a good foundation for it. But like I mentioned, it can seem a little daunting, I think. So don't be discouraged if you started reading this book and you thought it seemed scary. You can go back in and like dive into those CUDA pieces later, but you don't necessarily need to like know all this hardware layer to actually start building models and training models. Obviously, it can be useful, and this is probably good for you to come back to and understand what's going on underneath the hood for troubleshooting, especially when you are building something at scale. And that's when they talk about like parallelism and all these different things. But again, I think it's for someone who's building something at scale in production, and you really need these like optimization pieces that are going to make a big difference at scale. or if you're doing really, really large models. So I think it's interesting. But a lot of the stuff is abstracted for you that you're probably going to at least start out with on your day to day, like in PyTorch. And even like one thing that I'll talk about here, but just using this PyTorch compiler and PyTorch profiler that's built into PyTorch, like it already handles most of the CUDA stuff for you anyway when you're using PyTorch. That's why it's good for like deep learning, right? You don't have to really worry about it. It can work with CUDA and GPUs. It already does that with most of the libraries. They have kernels that are built in there. Same with even like more complex kernels for attention layers and stuff like that. But this is just more interesting if you want to dive back into it. And Ram said, chapter 16, inference at scale is most interesting. Did you read it? What was most interesting in there, or does it just sound more most interesting? I think it was. I might have the numbers wrong. I have chapter 15 here, but it is potentially possible that I put a wrong order here. So I'm going to go through if people are interested. Again, either we could go and go through each chapter, but I think what I'm going to do, if it's okay with people, is I'm going to go through just some of my takeaways. And I kind of try to break out of just from this book too, and then I have doc links for most of the stuff in here and blog posts. If you're interested, again, I shared the slide links, but I'm going to share it again. So if you do scroll down, starting at the slide 9, I started this kind of like my takeaway type of thing where I started trying to take a little bit more um, notes and then like pass it. Like I might ask Claude a question about it and kind of understand a little bit deeper. And then so I made these notes here, and then most of these again link out to more, like I try to have it more like you could go read the docs on this in a library, which again to me makes it feel a little less scary. Like you're like, oh, there's the thing I can go actually play around with if I wanted to. And it's a really good blog post. Actually, if you're just interested in kind of the hardware part, which one? I think it was this blog. I thought was really good. I'm going to share this link. This is how to optimize a CUDA matrix multiplication kernel for kubeless like performance. And I think it's written by someone at Anthropic. This is a really good read that breaks down like GPUs and how to do that kernel work. And then they mentioned they're hiring. This blog post might be old. I'm not sure, but um, they're like saying if you like this kernel type of work, like Anthropic's hiring a lot for that, which makes sense because they're hosting these very massive models at scale, right? Oops, I lost my stream window. All right. Someone said they joined a bit late. I haven't read the book. Is there a PDF copy? I always recommend going to look and buy the copy. So I linked to the official book site here. This is the book. If you want to browse the contents, should have links to buy it as well. Also, a lot of libraries, at least if you're in the US, a lot of the libraries here and universities will have some sort of like way to get the O'Reilly subscription or access to it through them. So if you're in the US, at least, I'm not sure about other countries, you can Google like your public library and plus O'Reilly and see they often will have something where you can go read them online or check out the book as well. I know I'm in Seattle. The Seattle Library has that. It's sometimes hard to find on the site, but I think again I would just Google like Seattle Library O'Reilly, and they have like if you have a library account or a library here, you can access the O'Reilly online portal. And I think now it actually has most, if not all, of the books. It used to be more limited like years ago, but it's a good resource if you're looking to skim these books or you want to start reading them or just read them through your library. All right, so I'll go through real quick. I probably won't read everything word for word here, but some of my top takeaways that I thought was interesting from the book, and then thinking about just AI system performance engineering. For me, I think the big takeaway from this book is, and I think they mentioned this at might be at the end or at the beginning, where the kind of the core philosophy though through the book is you should profile first and then optimize after measuring. Totally makes sense, just like measuring most evaluation type things for any type of performance, like accuracy or whatever as well. But again, like practically, if you're using PyTorch, like I assume most people here are, then you can check out the PyTorch profiler. I won't share every link in here. I'll just share the slides again, actually, because otherwise it's going to be a lot for me to open and share. But you can check out the PyTorch profiler. Should give you some insights of how it's performing. And then, like I mentioned, there's the PyTorch compiler. I think I might mention that on the other slide. But that's going to probably be good for a lot of the use cases, unless you're in a little bit more of a niche area where you really need optimization. You want to like hand build a kernel. And like I mentioned, the PyTorch compiler uses Triton under the hood to actually build kind of custom kernel after its profile. And then there's also this NVIDIA Insights. If you want to go deeper into measuring the compute, that seems interesting as well. Again, for me, I think probably just a lot of the things I'll be working on, I'm going to start using the PyTorch built-in and then the compiler and see how that works for me. And then the other area, and you're probably somewhat familiar with this, at least you've been hearing about it, maybe you haven't implemented it, but it's KV caching and inference optimization. I think this is from that that inference chapter. Some of them kind of blended, so I forget exactly. But this is, where LMs generate tokens, and if you think about it, they like how they actually work. It's easy to forget if you're just using the chat all the time, but they generate one token at a time and taking that whole sequence and then generate the next token, which requires attention over all those previous tokens, and that's where KV caching comes in. Like I think most of the places that have like deployed LMs at scale use KV caching. So they cache the previous steps, and you're not really rerunning attention across the every single token every time. So it saves those computed keys and values, which can add up quite a bit over time if it's like a really long string, right? Like if you have a really long sequence of tokens, the KV caching can save quite a bit of time. And I think like a lot of other people, including Hugging Face and stuff, had their own implementations of some of this stuff for inference. But they even just deprecated it, I think, because they just point to VLM or SGLang now. I know I said I wasn't going to share every link. This go check them out. Or SGLang, the other big one. I'm sure there's some other ones too. These are the two most common ones that I see around. And then again, you have the links to like the original paper in here and stuff like that. They talk about how they do this pretty efficiently. VLM came out. And NVIDIA has one too, of course. And then I already mentioned this. I kind of combined this, I think, into that first step of profiling first. But the Torch compile and PyTorch optimization stuff that's just already built in is really cool. Torch compile, I won't open these into every link. Like I said, they're in these slides if you want to go and click around to these. The compile came out in 2023 when PyTorch 2 came out. And like I mentioned, that uses OpenAI's Triton underneath to kind of automatically build those kernels and make them more optimized. And the book even says, and if you read the docs, like it says, this isn't going to all the time a ton, but that's where the profiling comes in. You profile, try it out, see what happens. And there's some trade-offs for it, but it might be interesting for you to check out. And I think for a lot of use cases, it would be easy. It's only like one line of code. You're basically just wrapping your graphs for you, and you might see a big improvement there. It can't do everything. So one thing it tries to do, like if you're doing a training process or you have a big model, they use something called kernel fusion. So in the normal eager mode, every time it does the operation, like if you're doing matrix multiplication and then doing something else in your model, each one of those actions basically gets written to the VRAM in between each one. And the kernel fusion tries to fuse together those actions when they can, so they don't have to go back and forth between the VRAM. That's often where kind of the latency comes from. So it'll try to automatically figure that out for you. But again, it's not perfect. And they even mention like handwritten kernels like flash attention, which I think there's another section where I talk about this more and I link out to it. That's like a handwritten one. I think they're on 3 or maybe 4 or 5 now. I don't remember. But it's a kernel layer that people use that we'll talk a little bit more. But that was a handwritten one. So they're just saying, try it, but it's not going to be perfect. If you really do need optimization, you still might have to handwrite a kernel potentially. But profile before and after, and see if there's a speed up difference between. Quantization, I've done a fair amount with this before with like LMs. I guess some quantization too from other model types a long time ago, which I think the field's changed. There's some like the Torch compile wasn't out when I was working with more quantities models for like computer vision. We used like Onyx runtime and some other ones, which I think are still valid today. But the field I think has changed. I need to catch up what it would be for some of the other models. But for LLMs, I've used the bits and bytes library to make it really easy to quantize models for training. So it mentions in here, right? If you have a really big model and you don't have that big of a GPU, or even have a pretty big GPU, it can't fit in all the VRAM. Like this 70 billion model, I think this is right, where the 7 billion model and the float 16 need, but you can downsize it to like a 4-bit, and then it can fit in like a 35 gigabyte GPU. So a lot of stuff like that you'll see all the time for training, but also inference as well. And again, I've used the bits and bytes library. Has anyone else used any of the other ones? So there's a couple other ones that came up. Was AWQ, which I haven't used, and then GPTQ were some other ones I saw on that. I've used the bits and bytes ecosystem. Works really good. I've done some workshops on it in the past, and I think actually in the next month I'll probably do some more on it as well with some of the larger LLMs, and maybe doing fine tuning again with different quantization techniques. You can also use LoRa and QLoRa. So LoRa is where you aren't training a whole model; you're just updating a part of the model, and that's a lot lighter weight tuning as well. And then QLoRa, so you can fit that model onto a GPU, but then it uses less computation to actually update the model. Which I did not mention in here. I actually don't remember if the book. I don't recall it in the book. I could be wrong though. There's a lot in the book that I don't have summarized here, by the way, too. These are just some of my thoughts after reading some of the chapters. And then distributed, how you want to think about, when you're doing stuff at scale again. When a model or data set is too large for one GPU, you need to distribute it across multiple GPUs or nodes. There's data parallelism, which is you want to replicate the full model on each GPU, but then you split the data between them and then aggregate the gradients between those models afterwards. Tensor parallelism, where you split the individual layers across a GPU, so each handles part of the matrix multiplication, and then you can kind of combine those back. Pipeline parallelism, where you split the model by layers across the GPUs, find those back as well. This is something that I think you're doing when you're training those massive large language models that everyone's using right now. You have to spin up. There's a lot of huge computer vision data sets or self-driving car data sets. We have 3D images as well in like healthcare, which could be really, really big as well. So you have to think about how would you scale up the compute to manage that. Check out union.ai as a shameless plug. And then NVLink, that also talks about the hardware between these. NVLink is like the type of connection between them. So I think I could be wrong, because I got a DGX Spark recently, and I think if you're connecting both of them or multiple ones together, I think you actually use an NVLink between those two GPUs, which I don't have, and I don't have two, so I don't need one yet. Memory optimization. So running out of VRAM, I think, is just a common problem that everyone faces. Like if you've been in the AI engineering and you're trying to train models, you probably run into this. I know I have. Or you might just have an amazing GPU and you've never run into it. That's awesome. I wish I had like a H100 at home or something like that. That'd be great. That's why I got the UDX Spark, because it has 128 gigabytes of memory, which is awesome and really good for a lot of the models. And then if you go and do the quantization, you can actually fit a lot of the large language models on there as well. But you have things like gradient checkpointing, mixed precision training, gradient accumulation, optimized memory, all these different things that you can kind of do to help optimize for memory in your VRAM. And then flash attention, we kind of mentioned this before. It's a type of handwritten kernel that is specific around attention. So instead of using normal attention across the whole sequence of tokens, it does kind of a tiling across them, and it doesn't block out. I think this the quick summary is that it doesn't block out the entire, and it kind of just adds it as it needs. And I think that's in, or actually, sorry, that might be in the VLM paper. I think I might be confusing VLM with flash attention now. Too many concepts meddling in my head at the same time. No, no. So yeah, a flash attention moves less data between VRAM and on-chip memory. And you can go read the original paper here. And let's see, don't think I have too many more of my takeaways. Speculative decoding seemed interesting. I needed to dive deeper into this topic as well. Also already implemented though. So if you're using like a VLM and you think you need this type of thing, a lot of this stuff's already implemented in those common frameworks that you can use. This does the exploit that most of the tokens that are being predicted are actually pretty easy, and a smaller and or cheaper model can have predicted the same thing as a large model. So it can actually predict or start generating those tokens with a cheaper model, and then basically verify on like one pass with the bigger model and get consensus if that's like what it would generate. And if you do this, it can be, I think, a lot cheaper, and you don't get the trade-off of quality because basically you have this like sanity check for the model in there. But the it can take extra time, especially if it's actually not generating good stuff. And then I won't go too deep into this, but I thought it was interesting just diving more into the GPU hardware architecture. And again, there's a whole really good chapter on it, but it breaks down like, what is L1 cache, what is L2 cache, what are warps, what is VRAM, what are the connection cables between all those things. Um, I think someone had mentioned earlier that they got to this chapter and then they were like, "There's a lot," or maybe they like this chapter and one of the other chapters was a lot. This is an interesting breakdown though, like a huge, I forget how many pages it is, but it's quite long chapter on everything going on in a GPU. And then the custom CUDA and Triton kernels. We'd already mentioned this several times, where there's a lot of stuff that can handle generating those for you now, and often you might not be handwriting them. But if you do need to write them, this talked about how you would do that in CUDA with like the C++ library from NVIDIA. And then the Triton kernels, which I've been seeing just a ton of in the past couple of years, which is again a Python-like language that compiles to GPU kernels. And this is from OpenAI. I think it was in 2023, a little bit before or I forget when PyTorch 2 came out. It was 2023 or 2024, but it was before that they released this, and then now PyTorch uses it in the backend for that torch compile method. And then the book has a giant thing at the end too. There's like 175 plus, maybe 200 item performance checklist that's really comprehensive. Probably too much for what I would do most of the time, but really interesting to go through if you want to see like what a massive checklist would be for AI systems with like these field tested optimizations that they have. So again, some of my takeaways here, and then we'll see what people want to talk about in the chat. I have to break down more of these other chapters, but I don't know if we need to go through them all, especially if no one else wants to come up and actually discuss it, which is totally fine. I probably won't go through every single one. Like I mentioned, this is a really, really long book, and I think it sounded like a lot of people didn't go through everything, which is totally fine either, or totally fine too. Let's go back to the chapter list here. Right. What do people think? We did a little bit of an overview, at least, of some of the takeaways I had. There's a lot going on in this book, like I'd mentioned. Are people going to go check this book out later? Or keep this in mind, if you don't need these things yet, but then you might in the future, I would go buy this book and study up the chapters that you think are relevant to you. I see a lot of people in the stream. Haven't seen something in the chat in a little bit though. Oh, and I do see one from Jay that he says he's looking to dig deeper into profiling and benchmarks. The profile first approach emphasized here validates some hard lessons I had learned last year while working on some internal projects. Yeah, and I think they have a good kind of just format of, again, I think depends on what you're doing, but for a lot of people, probably the built-in profiler and then try out the built-in compiler. Again, that might not work for your application every time, but probably interesting for you to look at. And built in a PyTorch, so you're probably running stuff in PyTorch, cracking up on a LaCroix. Oh, and somebody said O'Reilly had a free trial that lasts for maybe a week. They started reading and paused when the trial stopped, but you can take a quick look this way. Yeah, I need to look at them again and see if they might have something for groups where I mean, I don't think you get a free book every month or anything, but I think they might have something where maybe we can get a code that will give people like a 30-day access or something like that. I need to follow up with them again on that. Like I mentioned too, at least in the US, a lot of the public libraries can give you access from what I've seen, and universities as well. Also, you can order the hard copy books and stuff, but I know some of the new ones too are kind of pricey, like this one and the last one, maybe even the last one before that, because they're so new and kind of like the hot and demand books. I think they're a little more expensive than some of the other ones I had gotten from O'Reilly before. Any other questions or thoughts? Oh, and like I mentioned, you can also check out the code. And Jay said, "Get O'Reilly through the library." That's what he's been using for the last year. So again, GitHub to this book's GitHub as well. So it does have a lot of code examples and also walks through. I mean, it doesn't have the chapter contents, but it kind of has the what's covered in those chapters, which could be interesting start for place for you to start as well. Oh, and it looks like you might be doing a hands-on course potentially, which could be cool. But the code is in here, so if you go through, he also does a ton of meetups. I think some still online that are cool to check out. But yeah, if you want to go through and look at correlating code for those chapters, I forget which one was like the the profiling one or compiling one, but you can go in and you can see there's a lot of code examples and documentation here for you to check out as well. And again, I'll share the slide links one more time too, since there's so many links that I have in the slides this time. If you want to check them out, oops, share it through here. If you want to check it out, you can. Cool. All right. Well, any other uh, questions or thoughts? And also, what books, if you have any books or topics, we can look for books on those topics or see when they're coming out. So there's a whole bunch that are in early release right now. So actually, this one's already out. We read it. Some of them aren't out yet that I have listed here. And I don't like posting them because sometimes or using or scheduling to read them yet because sometimes they get delayed by months. So I always wait for them to kind of officially come out or be officially announced. That's like the designing data intensive applications is coming out, I think, like next week or March or something like that. But it's definitely going to be out by April, the time that we have it listed to read, because like prints are happening right now. JS, what is your takeaways about good put? Oh yeah, I think in the first chapter they talk about the term good put, which I don't know if anyone else has heard of, but really that's just the term of measuring what I forget how it's summarized, but I think it's basically measuring the term or sorry, measuring what the hardware can practically do for your like AI system and running models, I guess. So think of like training or inference, but it's not measuring all the other things like startup time. So you're kind of eliminating that and then scaling what you're measuring down, I think specifically to the throughput of the things you want. And I think they call that good put. Oh, and Ram or Ram said, I have a DGX Spark. So it said, you have a DGX Spark. I just got gigabytes version, maybe we can do a book club session on some subset of DGX Spark docs. Yeah, or I'd be down to do something on a DGX Spark, and it doesn't have to necessarily be through the book club part. We can make a separate event on it. So if you want to sync up on it, that'd be awesome. And I just got it not too long ago, so I haven't fully played with it. I've been trying to run some kind of state of the art generation models of different modalities. So doing like music generation with an open source model, and then trying to find which ones are going to be best for like video generation. And I kind of have the idea I want to build like a pipeline that uses those modalities together. So you could think of generating like a video, something like a commercial. So you have like a video generation, music generation. Maybe you start with an image from image generation that goes to video, and then you could have narration, so like text to speech, and then obviously there's a lot of great foundation LM models for generating text. But I thought it'd be fun to kind of combine those together in a pipeline, and then maybe revisit that every quarter or something like that, and see kind of what is the state of the art for these models right now. That's actually one reason I got the Spark. It's just it's really hard to run those models without a big GPU. And the music model I was using is called Ace Step. Let me bring that up. We're going off topic a little bit here. Really good. Bring this in. Yeah, this is the music generation model. If you're interested, check it out. I thought it was really cool. They also have a Hugging Face space that you can mess around with. So you can do some generations there and test out the quality. I thought that open source music generation was like pretty far behind like Suno, which is like a commercial app. But A-Step actually does a really good job. In at least from my experience, almost comparable with Suno. Sometimes it sounds not great. Sometimes it sounds really good. I actually think from again just from my experimentation that it might even have more vocal range, which is cool for like singing. Oh, and one thing that I didn't mention, um, again, while we're here, well, I mentioned this that I'm running a workshop tomorrow. If you want to join that, since I already have this up, I'll share that link again. But I was actually going to bring up that. So something that's come up with the like AI book club sessions is like we used to run events weekly, and it was really fun to have like a community check-in weekly and see what people were working on and talk about the book chapters. But it was kind of hard to read a book or read the book every single week. So I thought it'd be more fun because I like doing hands-on stuff and talking with other people. Seems like that's the case too. Is that I mean, probably I'm sure there will be some weeks where it doesn't happen, but the idea is hopefully to try to maybe do almost a weekly stream with a topic in mind. And then during that week, like the topic will be posted before, and then you can learn about that concept or build something with that concept. And the idea is like a lot of this you could probably find out or learn a lot, like build a quick demo, right? It doesn't have to be a production scale app. You could probably learn enough about a topic, like in this case, MCP, and build your own MCP server with like a library called like Fast MCP. They make it pretty easy. Um, you could learn enough about MCP to like know something and build something with it just by probably spending like an hour and a half. You could obviously spend more time than that, but it would be cool to come up with like a weekly topic and then build examples, communicate maybe in Slack during the week, and then we can talk about the demos here. So I would do like a presentation maybe on what I built, but then hopefully other people would want to talk about what they built and be kind of a community discussion and demo session around a topic. And I think that would be really cool. And I don't want to schedule the topics too far out. I have two right now. First one is this model context protocol. I'll share the link for that. The next one is agentic search with Tavily. Tomorrow's workshop also uses the Tavily API, but I wanted to get more familiar with it. And then after that, I don't have any booked. So if you have topic recommendations, let me know. They should be somewhat specific. So, for example, not just reinforcement learning, for example, is like a big field, but it could be like reinforcement learning for LMs for like GRPO or what deep Q learning or something like that. So something we could actually like hone in on for that week and build a demo and then discuss it. I think this would be pretty fun, and then you're not tied to a book We can change those topics. Like I said, I don't want to book too far out. So if a cool, interesting model comes out, we could pivot for the week later or whatever to talk about the model and maybe like do a fine tuning example or deploying or something like that. So what do people think of that? I know this is from feedback that I've got from people from events. I think this hits kind of what a lot of people wanted, a little bit more hands-on, building something, communicating. And then if you didn't that week too, it's fine. You come into that stream, you get to learn about this topic and see hopefully, definitely a demo for me, probably. I hope if I get to it, but other people as well. But yeah, the first one's posted for model context protocol. Does that sound interesting to people? The silence. Maybe it's not interesting. Based on what other people said, I think it'll be cool. And I'm excited about it because I think it'd just be cool for like it's like part of it is accountability things for these topics. Like I always want to go learn this thing, and I don't set aside the time. And I find if I have an event, especially when we're talking about it, or even if I'm not the presenter, like I used to do this years ago when I first moved to Seattle. Um, I was taking online courses, and it was kind of hard to like just study online, and so I wanted to go in person, and so I would go like or I wanted people around me, so I would go to meetups and talk about what I was building, and that helped a lot too. But I think this will be really cool to have these specific topics. Arun said yes, they love the idea of working on simple projects and discussing. Awesome, yeah, I think it'll be really fun, and then you'll be able to again talk in the chat if you want to come on the stream. You can as well and present your project. We'll figure out how to like projects or something like that. I haven't gotten that far yet. I started a GitHub, kind of trying to organize it, but it's not there yet. But yeah, I think and someone said they're new to AI. I think this will be a fun way for you to potentially learn different topics as well. Again, even if you didn't build it, you'll probably see some cool presentations from people. While people are here, what topics would you want to see next? So if we already have model context protocol MCP, and if we had agentic search is going to be the next one with Tavily, what would be some other topics that you would want to dive deeper in? And it could be a topic or maybe a specific tool. So usually I think the tools tackle a topic, but I think trying to make it pretty practical for people to dive in. I will probably often have a tool in mind that I'm going to use, but it's okay if you deviate from that tool during the week as well and you want to try something else. And someone said, nice to have sessions where people can actually exchange a bit more on their progress projects, where they're getting stuck and showcase wins, etc. Yeah. I mean, well, hopefully this will tackle some of that. It might not be like your other bigger projects or something like that. That could be potentially something else. People have said like they wanted. I think one time we did like a vote on it. People wanted a stream where you could like showcase projects, but it's just hard to organize, and people often don't show up and stuff online for kind of the more casual things like this to present. So I think this is going to be a good way of having a topic where we'll have like a specific thing that some people will probably go and research, and then we can discuss it. But hopefully, this will tackle some of the things that people were wanting. Oh yeah, this first one is going to be March 27th. So the idea, again, like there'll probably be a Fridays where I'm working at a conference or something, and I probably can't do it. But the idea is to try to have like a weekly topic. At least that's how I'm starting out. Maybe it'll be too much. Maybe it'll change to monthly in the future. But I think it'd be really fun to do weekly. And I kind of miss doing the weekly book club streams, but not because we were reading every week, because we were like discussing something every week. So it's a different architecture design patterns could be another good focus series for sessions. But I think it might be like a specific design pattern that you implement for this type of thing versus getting lost in like a whole bunch of different design patterns. Unless we have something like here's three, and then build demos and compare them or something like that. And I'm not sure what type of architecture or design pattern are you thinking of? Like for an AI system, a specific type of AI system, a type of model, different types of RAG. That's why it's too open ended of a question, I think. But if you have a specific one for like, actually, one thing I do want to do is like different types of RAG, and maybe it's even a series for the month or something like that of like implement this type of RAG and then this type of RAG and compare them later. Maroon said at this point they want to do two things. Hopefully, you're going to say what those two things are in the chat. Can't leave us hanging with a cliffhanger like that. Also, again, keep in mind what books you want to read next. So again, you can message me on LinkedIn or join the Slack channel. I'll share the Slack one more time as well. Also, you can say hello in the Slack in the introductions. There's also the AI reading club channels in there, and then there's the introductions channel. It's kind of fun to have a more permanent one since I kind of lose the chat here once I'm gone. So if you're working on anything interesting, throw it in there. And then yeah, I'll throw this in again too. So if you want to also check out the open source orchestration platform we're working on. So the just a little history of like the Slack channel is the Flight Slack channel. Flight, the open source AI orchestration uh, and inference platform. So a lot of people know Flight for like training models is what most people use Flight V1 for. Flight V2 is coming out very soon. The SDK is already out. There's actually some really cool stuff in the SDK that you can use without even a Kubernetes cluster that I'm excited about. Again, I'll be talking more about this probably tomorrow and next week and at some other upcoming workshops. This, isn't a official flight event here or anything, but it's relevant also to like the book that we covered today. But the history of what the Slack is. So if you were wondering why it says Flight Slack, this is our open source space for Union. We also have Pandera in there as well. Creator of Pandera is my manager, actually. All right, we got the two things now. Everyone said at this point they want to do two things: identify a problem with just start with, and use tools like Claude Code to build and understand what the fuss with agents is all about. To read books that help me understand the foundations. Currently reading Understanding Deep Learning. I'm not sure if you've seen that book. Let me look it up real quick. Understanding Deep Learning. I think it's this one. Understanding Deep Learning. Yeah, I haven't read this. Is it good? Ooh, looks like it has like a notebook for each chapter. That seems cool. I'm always looking for good books to recommend to other people too. Also, if it's one potentially the group might want to go through later, we could. 1D diffusion model. I love hands-on books. This looks fun. Cool. Yep. And you can open in Colab. Nice. This looks like a cool book. Thanks. I'll take a look at it. And actually, we'll bookmark it. I'm going to throw it in the slides as an option to read next. Just paste the link here. Yeah, if people are interested, let me know. Cool. Well, we're almost at the hour here, so I do have to go back and do some other work. But again, connect with me on LinkedIn or join the Slack. And if you have questions about anything that we covered today, let me know, or thoughts. And then also about what books you want to read next, what topics you want to learn about. And then hopefully I'll see some of you at the workshop tomorrow as well. If you're interested in building agents, might be a good kind of intro to a couple things. One, like building agents, if you haven't built them before. Maybe you have built an agent before. We'll also be talking about how this would look in flight 2. So you get kind of scalable and durability, things that maybe you hadn't implemented before. And then we're going to be using LangGraph. So if you've never used that framework before, you'll see what that looks like. And we'll be using Tavily, which is the search tool that makes it easy to do search from like Python scripts or from agents, is like what it's built for. It actually just got acquired, I think, last week or the week before by Nebius. So I think they were doing a pretty good job of it, and Nebius acquired them. So several things that hopefully will be interesting, but kind of designed for hopefully it'll be useful no matter what your background is, whether you've done some agents before or no agents at all. Hopefully one of those things will be interesting to you. And Rune said they're working on the notebooks, as they haven't worked with notebooks at all, despite having a background in Python. Well, it depends what you're doing. You don't always want to use a notebook, right? I know quite a few people, like especially data science, love notebooks. I like notebooks for like storing visualizations and testing stuff in, and actually running workshops through makes it pretty easy too. But I say um, I've gone away from using notebooks a lot of the time in my development. I like organizing my code in different packages and stuff now. So, and Ram said, "Cool, thanks again for doing the sessions." And Daniel said, "Thanks, great session, awesome. Thank you all for coming out." And yeah, sync up with me, Ram. If you want to message me on LinkedIn or in the Slack about doing something with DGX Spark, I think that would be really fun. We do some sort of I don't know, show and tell type of thing, and maybe we can run some models. If people have questions of what things look like on there too, or something, maybe it'd be kind of information, an interesting information session for people like wanting to play around with a DGX Spark. That'd be kind of cool. So that might be another thing coming up. All right, I'm going to end the stream. Again, thank you for everyone coming out. Thank you for everyone talking in the chat. I will hopefully talk to you again at another book club event, or the AI build and learn. That's what I'm calling the shorter kind of hacky section events, and at some other workshops. All right, I'm going to end the stream. Thank you again. I'll talk to you all later.